Welcome back, Physics 30. This is Speed Velocity Part 1 for the Section 1D. Corresponds to 51 to 62 of your booklet. And in this video we'll be looking at defining speed, average speed, and velocity, distinguish between speed and velocity, recognize situations in which it is essential to differentiate between the two of them, calculating speed velocity, looking at information from charts, tables, and graphs, and solving problems involving speed and velocity. So first of all, speed is defined as distance over time. As a formula, we usually refer to it as V equals d over delta t, or change in time. And you notice I don't have a half arrow over the d, so that implies that it is actually a scalar quantity. The direction does not matter in this case. So if we look here, speed is a scalar quantity as well because distance is a scalar quantity. Speed is defined as distance over time, so if it's a scalar, then the overall result is going to be a scalar. Velocity, however, is displacement over time. So the idea of that resultant displacement that we looked at in vector addition. And as a formula here, you can see it's very similar. V equals delta d over delta t, except you have the half arrow over the v and the delta d, implying that it's a vector. So if you compare it to the previous one, no half arrow. In this case, we do have a half arrow, so it needs a size and a displacement. So velocity is a vector quantity because displacement is a vector quantity. Average speed, we'd be looking at the total distance over total time, and the word average implies that the speed is changing and we're looking at what happens overall on the average. So the person could have been moving for some time, stopped, then moving again, and you're actually figuring out the average. Whereas just simply saying speed indicates a constant movement, a constant distance over a constant time. So here the formula is very similar, V equals d over delta t, but the little AV there represents average. So as I kind of mentioned already, how is average speed different than just plain old speed? Speed, you must have a constant movement throughout, whereas average speed, over a certain time period, what is the speed on average when speed is not constant? So if you're speeding up, slowing down, that is when the average speed comes into play. Okay, so there's some examples in the duotang there, and if we look over here, a fox moving at constant speed travels 300 meters in 50 seconds. What's the speed of the fox? So V equals d over t, because we're looking at speed, so it's just simply distance over change in time. 300 meters over 50 seconds, 6.0 meters per second. Now you notice up here I have a little bit of a calculation. If we have a number in terms of meters per second, and if we're looking at converting it into kilometers per hour, you can see the conversion set up here to end up with hours on the denominator. 60 seconds is 1 minute, so cancel off the seconds. I'd have meters per minute if I stop there. But if I go one more step, 60 minutes is 1 hour. And then changing meters to kilometers, you can see overall what I do here is 60 times 60 divided by 1,000. That ends up being 3.6. So if you have a number in meters per second, multiplying by 3.6 would change it to kilometers per hour, or vice versa. If we have a kilometers per hour, changing it to meters per second, divide by 3.6. So you may wish to copy that down as a simple way of converting from one form to another. Okay, so here we have B. Trish whizzes along the highway in her new Mercedes-Benz. She travels 80 kilometers in 1 hour, 50 kilometers in another hour, and 100 kilometers in another 1 hour. What is her average speed? So you can see it's not constant throughout. She's speeding up, obviously, because the distances are different. So first of all, the total distance. If we look here, she went 80 kilometers, 50 kilometers, and then 100. So it's a total of 230 kilometers, and it's 1 hour, 1 hour, 1 hour, so a total of 3 hours in which that was done. So average speed, total distance over the total time taken, 76 0.7 kilometers per hour. Okay, so a little bit different than the other one. Jake loves his new motorcycle. He takes it for a spin and travels 70 kilometers in 1.2 hours. He stops to let everyone admire it for 0.3 hours. Then he zooms off and going 100 kilometers in 1 hour. Calculate the average speed. So it's very similar to the first one there. Maybe pause the video and see if you can work it out yourself, and then press play and see if you achieve the right answer. So if you had time to do that, the total distance, 70 kilometers, and then yes, for this time period, 0 kilometers, plus 100 kilometers for the third part, because there's basically 3 separate parts there. And then the total time, 1.2 hours, 0.3 hours of doing nothing, but you still include that time, and 1 hour, so that's 2.5 hours, so that's a total of 170 divided by 2.5, 68 kilometers per hour. Okay, this last one here, Julie travels in her convertible at an average speed of 27 meters per second. It takes her 1.4 hours to travel a distance. How far did she travel in meters then in kilometers? So first of all here, we're looking for D. We know what V is, we know what T is, we're looking for D. So we could look at this one of two ways, either solve for D by multiplying each side by T, or if you use this little triangle manipulation here, V equals D over T. Therefore, if I'm looking for D, V and T are side by side, so it's V times T. Or if the question had me looking for T, it's D divided by V. Okay, so first of all, we have 27 meters per second. That's the unit I want speed in. We have hours though. We need it to be in seconds if we're using this, because the time has to be equivalent. So you can see here I converted my hours into seconds. 1 hour is 60 minutes, 1 minute is 60 seconds. So you can see my units cancel off here and I'm left with seconds. So that's 5,040 seconds. So substituting it into my formula here when I've solved for D, V times T, and you can see why we have units of seconds here, because they should cancel out, and we're left with 136,080 meters. There's 2 sig figs here, so you can see I kept the 1 and kept the 3. The 6 tells me I need to bump the 3 up to a 4. So it's 140 meters. And then lastly, to solve for kilometers, 1,000 meters is 1 kilometer, so I divide by 1,000 and I get 140 kilometers. Okay, so I think I'll stop the video there, and we'll have part 2 shortly.